So let's continue with the examples on Pythagoras theorem. Let's take the fourth example. In this question, angle ABC is less than 90 degree. That means it's an acute angle, and AD is perpendicular to BC. AD is perpendicular to BC. We have to prove that AC square is equal to AB square plus BC square minus 2BC into BD. So what we are given, that angle ABC is less than 90 degree. This has nothing to do with our result. It only means that the perpendicular drawn will be inside the triangle. If angle ABC is acute angle, which means when we'll draw perpendicular AD, it will lie inside the triangle. So another thing which we are given is AD is perpendicular to BC. So let's apply Pythagoras theorem. In triangle ADB, applying Pythagoras theorem, we have AB square is equal to BD square plus AD square. And again in triangle ADC, we have AC square is equal to CD square plus AD square. Okay, so this AC, both are same here. So let's take this equation and move further. So we have AC square is equal to CD square plus AD square. We don't have AD in our final equation, so we'll eliminate the AD. So eliminating AD will be equal to AB square minus BD square. So we'll write AD. We'll substitute the value of AD from this equation number 1. This is equation 1. This is equation 1 and this was equation 2. So we'll substitute the value of AD from equation 1 in equation 2. So writing AD square as AB square minus BD square. Okay. AB square minus BD square. So we have AB square also, AB square. Then these two terms. So again we have AC square is equal to AB square plus CD square minus BD square. We want BC in our final term. Okay. BD and DC. So let's eliminate this CD also. So CD, from this the diagram we can see that CD is equal to BC minus BD. Okay. Why we are eliminating CD? Because BD we have in our final equation. So I leave BD as it is and CD I will substitute. So CD whole square will be BD minus, this is BC minus BD. Should be BC minus BD. BC minus BD is CD. Okay. So let's substitute this value. of CD here. So we have AC square is equal to AB square plus CD square. So opening this, we have BC square plus BD square minus twice of BC into BD plus, no, then this we have done, then this term minus BD square. So this we have substituted from CD. So from here again BD and BD will get cancelled. So what we are left with is AC square is equal to AB square plus BC square minus 2 BC into BD. So this is the final result which we have to proved. Hence proved. Okay, now again take the another example. So this is also same as the previous one. In this we have angle ABC greater than 90 degree. That means it's an obtuse angle. It's an obtuse angle. So what does it means? That the perpendicular drawn will lie outside the triangle. And again AD is perpendicular to CB. We have to prove this result. AC square is equal to AB square plus BC square plus 2 BC into BD. So again we'll apply Pythagoras theorem. So we have two triangles to apply Pythagoras theorem. So taking the first triangle, we have triangle ADB. In triangle ADB, we have AB square is equal to AD square plus BD square. And again in triangle ADC, we have AC square is equal to AD square plus DC square. So again we have AC. So let's take this equation. Let this be equation 2 and this be equation 1. So taking the equation 2, we have, why we are taking equation 2? Because this term is common, we want AC in our final results. So we'll take equation 2 and we'll continue with it. So we have AC square is equal to AD square. So again let's substitute AD from equation 1. So AD will be equal to AB square minus BD square. So this we have substituted as AD square plus DC as it is, DC square. So again we got AB square in the final result. We want BC. BD. We don't want CD. So again let's eliminate CD. So from this diagram we have CD is equal to CB plus DB. Okay, CD, this whole length is equal to this CB plus DB. So let's substitute this. So AC square is equal to AB square minus BD square. We didn't substitute BD because BD was in our final result. So we left BD as it is. So substituting CD whole square as BC square plus BD square plus 2 times BC into BD. Okay. So again BD cancelled. So we are left with AC square is equal to AB square plus BC square, this, plus 2 times BC into BD. Hence our final result is proved. Hence proved.